Junction, what's your function?
Hooking up words and phrases and clauses.
Conjunction, how's that function?
I got three favorite cars that get most of my job.
Okay, this is not about conjunctions. This video is about functions, though. We are going to be talking about functions, and the objective of this video is to understand and work with the vocabulary of functions. A function is a relationship that assigns exactly one output value to each input value. Notice relation. We've been working with relations, set of ordered pairs, the graphs, the tables. Same thing. It is a relation, but it's got a special property that every input value has one and only one output value. Function rule. Function rule is an equation that describes a function. For example, here we have f of x equals 2x plus 5. That is an example of a function rule. Function table is a table that organizes the input values, output values, and the function rule itself. Here we have that same function rule with its input values over here and the output values over there. And in the middle is where we show the work of how we get the output with the input. So input, function, output. That is a function table. Input. Input is data to be entered into a function. It's the x values. X values are always going to be the input values. Output is the simplified result of a function. The y values. That f of x really is, well, we're going to talk about that in a minute, but it's the simplified values of the expression. Independent variable. The independent variable is a variable that provides the input values of a function. Independent variables are the x values. Input values. Independent variables. Same thing. Dependent variables is a variable that provides the output values of a function. The y values. The dependent variables depend on the independent variables. The independent variables are the ones that you get to choose. The dependent variables are the ones that are a result of multiplying, adding, subtracting, or dividing something with the independent variable. F of x is read as function of x, or as I just read here, f of x. F of x is like saying y. Well, we used to say y equals, we're now going to say f of x is equal to it. It's a more flexible naming convention than just plain y. If you had multiple functions on a graph, you would want to have different naming conventions. And f of x lets you do that. You could have f of x, g of x, h of x, y of x, some other thing of x. That helps you, that gives you more flexibility there. It also allows you to provide more information. If you did f of 6, it tells you how the function at 6 is worth whatever it turns out to be, which is a little more descriptive than f of x, or just plain y equals. Here we have a function. F of x is equal to 4x. And we're asked to find the function value when x equals 6. So we're looking for f of 6. Notice how I replaced the x in the f of x part with a 6. I'm going to do the same thing over here. It's going to give me 4 times 6. Now this truly is 4 times 6. Over here, this is just a naming convention. I'm not doing f times 6. I just have the function of 6. So don't get confused by that set of parentheses. We are not multiplying over here. We're only multiplying here with these parentheses. 4 times 6 gives me 24. So the function of 6 is 24. Now, I could have written this problem without having to write that whole sentence. I could have asked for f of 6 if f of x is equal to 4x. This phrasing is asking the same thing. What's the value of this function when the variable is 6. Which variable is that? That would be the independent variable, the x value. Okay, here we're asked to create a function table for the function f of x equals x plus 5. Then state the domain and range. I'm not given any x values. I need to have them to create the table. I get to choose them. But you have to choose wisely. Remember, you must show that there's no change when you've got a negative and when you've got a positive. Or maybe there is a change. We got to see that. So you need to choose at least one negative number. Does it have to be negative 1,000,000,006? No. It could be negative 2, and that'd be fine. You need to have one positive number. Let's try positive 2. And there's no rule that says you can't make it a little easier on yourself. Let's plug in 0. 0 makes things a little easier when you simplify things. So can I use these 3 every time? Sure. Could I use negative 1, 0, and positive 1? Sure, but I think you need a little more spacing sometimes just to see where the function's going. I prefer to see 2s rather than 1s. Could I use something completely different? Yes, as long as you have a negative and a positive, and you really should use 0. Other than that, any 3 numbers will do. After you've chosen your numbers, you plug them in. F of negative 2 is equal to negative 2 plus 5. Opposite signs, larger minus the smaller, gives me 5 minus 2, which is 3. Sign the larger, it's a positive 3. F of 0 is equal to 0 plus 5. I've replaced the x with the 0 value. 0 plus 5 is 5. F of 2 is equal to 2 plus 5, which I hope we all know is 7. All right. So that is the function table. Now we're asked to determine, to state the domain and range. And remember, when we did domain and range, we have to have those fancy brackets in there. So here we have those fancy brackets, and we're listing all of the domain values, or all the x values. Does that mean I just write an arrow like this? No. We actually have to rewrite these. Negative 2, 0, and 2. That's in order from least to greatest. Then we do the range. Range is all the y values from least to greatest, which in this case happens to be the order they're coming in, 3, 5, 7. So there we have the domain and the range. That answers this function. All right, that was bound to happen. We all know that by now. All right, here we have a word problem. The school basketball team wants to have each player's name imprinted on the player's jacket. The cost is $75 plus $8.50 for each name. In this particular problem, I'm being asked, what is the independent variable and what's the dependent variable? Well, the independent variable will be the one that I get to choose. Well, as I'm looking through this, well, we've got a total cost, right? We want to have the total cost for something here, right? The cost. And we have a number of jackets, right? Well, what would be the independent one, the one that I can choose the value of? Can I choose the total cost? No, that depends on the number of shirts, the number of jackets. That's the independent variable. So we'll say let J equal number of jackets. So I've declared the variable, and that is the independent variable for this particular problem. How about the dependent variable? Well, we said the cost is going to be the dependent variable. Depending on the number of jackets, the cost will change. So we're going to say let C equal total cost. Now we're also asked for the function itself. So to create the function to find the total, whenever we're looking for the total goes on one side of the equal sign all by itself. C equals. We have $8.50 for each name. So it'd be 8.5 for each of the jackets. Each is a keyword for multiplying. Is that it? No. We also have this zero term, or this initial cost here of $75. That's a one-time cost, so it gets added on to the end, and there is your function. Declared variables, function, with the independent and dependent variables. All right, now we've gotten to the you-do. And this you-do is going to be two screens. So I'm going to show you this one. I asked you to pause I'm not going to ask you to pause the video. I'm going to show you this. Well, pause it and write it down. Then I'm going to show you the next one. And then we're going to go over the answers after that. So pause and write this. Good. Welcome back. Pause and write this. Welcome back. Let's go over the answers for it. F of 5 would be doing 5 minus 3, which is 2. So that's your answer for F of 5. In here, we write the function here in the middle. And we're doing, well, let's choose our -2, 0, and 2 again. I could use different ones, but let's use these. 2 times -2 plus 3 is -4 plus 3, which is -1. 2 times 0 plus 3 is going to give me 3. 2 times 2 plus 3 is going to give me 7. Now we're asked for the domain and range. And I'm going to cheat a little bit here by putting them right below the words there. You guys should have space to write them out. The domain is going to be -2, 0, and 2. And the range is going to be -1, 3, and 7. There aren't any repeats in either one of those, so I don't have to worry about eliminating the repeated values, which I would have to do for domain and range. Moving on to the word problem. The library charges 25 cents per day for overdue books, plus a $1 service charge. What's the independent variable? The independent variable would be the charge per day, the fine per day. So let's call that F for the fine. Let F equal daily fine. Did they use the word fine in the problem? No. Is that what it means, though? Yes, it is a fine. And there's also the service charge, but that's a one-time fee. So we don't have to declare a variable for it because we're just going to use that one-time fee. The dependent variable would again be the total cost. Or you could say total fine. The function is a total cost equal to the daily fine of 0.25 times the F plus the one-time charge of $1. All three of those are really the answer, but I circled the equation there. Good to go. I'll see you all on Monday. Leaving you with a little bit of that song, which is not going to play because I video timed it. All right.